circles. Our objectives here are to find the formula of a circle in center radius form and in general form. Draw a circle given its formula in center radius form, and draw a circle given its formula in general form. Center radius form of the equation of a circle. A circle with center HK and radius r has the equation x minus h quantity squared plus y minus k quantity squared equals r squared. This is the center radius or standard form of the equation of the circle. If the center is at the origin, the equation simplifies to x squared plus y squared equals r squared. The general form of the equation of a circle is x squared plus y squared plus dx plus ey plus f equals 0, where d, e, and f are coefficients. Algebraically speaking, a circle is the set of points x, y at some fixed distance r from some fixed point hk. Let's find the equation of the circle in standard form. I know my standard form is x minus h quantity squared plus y minus k quantity squared equals r squared. First, we identify the center. The center of my circle is at -1, 3. This is my h, k. So I have now x minus -1 quantity squared plus y minus k of 3 quantity squared equals, and then I find the radius. The radius is 2. So that is 2 squared. Clean this up just a little. So I have x plus 1 quantity squared plus y minus 3 quantity squared equals 4. Let's graph this circle. X minus 3 quantity squared plus y plus 2 quantity squared equals 9. My center is 3, -2. This might seem counterintuitive. The way I think about this is, what value of x would you put here that would make this squared quantity be 0? And that's 3. What y value would you put here that would cause this squared quantity be 0? And that is -2. Now the radius is the square root of this number. Since this number is r squared, the square root of 9 is 3. Now we have all the information we need to graph. Let's find the center, 3, -2, and the radius is 3. So we'll go left and right 3, up and down 3, and then try as best as we can to draw a nice rounded circle with that. If you're using paper, you can maybe use an apparatus to help you to draw that. Mine, if I don't use any kind of a tool to help me draw, it ends up looking like a football a lot of times. Let's graph this circle. Well, we're not asked for the center and radius this time, but I think it's a good idea for us to go ahead and find those. So, what is my h and what is my k? Remember, h is the number you would put in for x that would cause the squared thing to be 0. Well, that's just going to be 0. And k is the value that we would put in for y that would cause this to be 0. That's a 2. And the radius is the square root of this number, so 2. I have a center of 0, 2, and the radius is 2. So up, down, left, right, those 4 directions, 2. And then again, try your best to make a nice circle or use a tool to help you to draw that. Circles and general form. A circle has center 5, -1, and radius form. Let's find its general form. So we have x minus an h of 5, quantity squared, plus y minus a k of -1. So this would make that a plus 1, quantity squared, equals a radius of 4 squared is 16. That's our standard form. Let's find the general form. If you recall, in the general form, we have no squares of binomials. The only way we can get rid of the squares of the binomials here is to go ahead and apply the square. So we'll have x squared minus 10x plus 25 plus y squared plus 2y plus 1 equals 16. In general form, all terms are on the left side of the equal sign and a 0 is on the right side. We have the x squared and y squared terms first. Then we have the linear x and the linear y term. And then we'll combine 25 and 1 to be 26 and subtract 16. So we have a positive 10, all equal to 0. That's our general form. Now, the best form for graphing a circle is the standard center radius form. If you're given an equation in general form, you'll need to convert it to standard form. To do that, you'll need to be able to complete the square. Now, completing the square allows us to create a trinomial that factors as the square of a binomial. So let's study the table of squared binomials and perfect square trinomials and see if you can find a pattern and fill in the blanks. Here I have x plus 5 quantity squared. If I multiply x plus 5 times x plus 5, I'll have x squared plus 5x plus another 5x plus 25. Combining the like terms, I get x squared plus 10x plus 25. So here is the square of the binomial, and this is its product, the perfect square trinomial. Look at the next one, x minus 7 quantity squared. Again, we can write this out twice to multiply. X times x is x squared. X times -7 is -7x. -7 times x is -7x, and -7 times -7 is a positive 49. Combining our like terms, we'll have x squared minus 14x plus 49. Next, I have x plus 7 quantity squared. Let's skip this part and see if we can make it to the perfect square trinomial now without actually multiplying out the binomial. So x plus 7 quantity squared. I'm going to have an x squared. I know that this is a 14x. The pattern I'm seeing is that this is 5x from multiplying x times 5, but I end up having 2 of them. So this is related to this binomial by multiplying those two and doubling it. Here it is again. A negative 7x doubled is a negative 14x. And again, 7x doubled is 14x. I know this is always going to be positive, whether we have a positive here or a negative. This will be a positive 49 because I know that term comes from 7 times 7, or 7 squared. Now let's take away a little bit more. In this next example, I have no sign here and no number here. So what happens here is I know I'm going to always have a positive, and the number that goes there is 81. There's my perfect square trinomial from x plus 9 quantity squared. Now you can see the left side is all blank. This is the only information I have to go on. So now we need to look to see what the relationship is between this number and this number. You'll see 10 is double our 5, and 25 is the square of 5. But if we don't have this to look at, what is the relationship? If we would take 10 and take half of that and then square it, that becomes this number. Is that consistent? Half of negative 14 is negative 7. Negative 7 squared is 49. Half of 14 is 7. 7 squared is 49. Half of 18 is 9. 9 squared is 81. Half of negative 8 is negative 4. Negative 4 squared is positive 16. Now, once I have that trinomial, how does that factor as a binomial? This is x. The minus is going to go here because I have a minus here, and 4 quantity squared. Here, half of negative 2 is negative 1. Negative 1 squared is positive 1. In factored form, we have x minus 1 quantity squared. Half of 24 is 12. 12 squared is 144. Here I have x plus 12 quantity squared. You'll notice a pattern with these numbers as well. When we're factoring, it's always half of the middle number, or the square root of the third number of the trinomial. Now this one is a little more challenging because the middle coefficient is not even, but half of negative 3 is negative 3 halves. Negative 3 halves squared is going to be a positive 9 fourths. In factored form, this is x minus 3 halves quantity squared. Let's try this example where we have started with the general form. We are to convert to standard form this 2x squared plus 2y squared minus 24x minus 20y plus 114 equals 0. Then we'll identify the center and radius. So it looks like they're kind of trying to mask the fact that this is a circle because there are coefficients of 2 in front of both of those, positive 2, but everything is divisible by 2. So it's not really a big deal. We can just divide both sides by 2. If I divide the left side by 2, I'll have x squared plus y squared minus 12x minus 10y plus 57 equals 0. And beginning to get this into my binomial squared form, I want to group my x's together. I'm going to leave a space here so that I can complete the square on x. Then I'm going to put my y's near each other and leave a space to be able to complete the square. Then I'll subtract 57 from both sides. Now I want to complete the square on x. Remember, half of negative 12 is negative 6. Negative 6 squared is positive 36. Now it should feel strange to just add 36 to one side of an equation. We can fix that. Add 36 to the other side of the equation and you're keeping the equation still equal. Here, I have half of negative 10 is negative 5 and negative 5 squared is 25. Just like we did last time, I add 25 to this side of the equation. I'm going to need to add 25 to that side of the equation to keep it still equal. Now we can take these perfect square trinomials and write them in their factored form. X minus 6 quantity squared plus y minus 5 quantity squared equals negative 57 plus 36 plus 25 is 4. Now it's easy for us to identify the center and radius. The center is 6, 5, and the radius is the square root of 4, which is 2. It's interesting to note that a circle with a radius of 0 is referred to as a degenerate circle. Graphically, it will just be a point.